Welcome to Joey's Tech. Today we are going to brush up the basics of dynamic programming by solving the DP problem, which goes by the title maximum value with the choice of either dividing or considering as it is. It is a good problem that will definitely add a brick of wisdom and critical thinking to your foundation. To become an expert in dynamic programming problems, you need to solve the problems of varying levels. In Joey's dynamic programming tutorial, you get to learn the problems of basic, intermediate, and advanced difficulty. Thus, make sure you keep watching, and if you haven't subscribed to my channel already, then subscribe it right away and write I subscribed in the comment section. I promise I'll give it a heart and reply to it. Now let's move on to the problem statement of this interesting dynamic programming problem. The first statement says that you have a number n, and also you are given a complex looking but easy to understand function, which is this. You need to find the maximum possible sum with the help of this function from a given n, which we are considering 10 in this problem. So for this problem, the n is 10. The catch is the maximum function, which shows that the maximum sum can be either the number itself or the addition of the four parts. That means if you consider f10, then the maximum sum can be either the number 10 or the result of the sum of the expression f10 by 2, f10 by 3, f10 by 4 and f10 by 5. So the result is going to be 5 plus 3 plus 2 plus 2, 12, which is obviously greater than 10. Hence, the maximum sum is going to come out as 12. Note that we are ignoring the remainder and only considering the quotient. Now let's solve this problem using dynamic programming technique in the framework. But before switching to it, if you are enjoying this video, then hit the like button, and if you haven't hit the subscribe button till now, then click on it. Now let's begin solving this problem. For this problem, we consider n as 10. To solve this problem, we'll use an array of length n plus 1. So n is 10, hence there will be 11 cells in this array. As we move ahead, you are going to get the answer of why we created an array of n plus 1 cells. In this first cell, index 0, I'll put the value as 0, because if you check our condition down below, then the maximum is going to come out as 0. In this second cell, indexed by 1, I'll put 1, because again the below condition is going to give us 1. That's pretty much what the logic says, and that is common sense. These two cells will serve as the building blocks of our dynamic programming algorithm. Now we move to the next cell and we denote it using I. So currently I is equal to 2. Let's replace I with 2. So we get the first candidate in the maximum function as 2. And let's calculate the second candidate using this expression. So what value would fi by 2 give us? 2 by 2 is 1. So f2 by 2 becomes f1, and we have f1 calculated already in this cell, indexed by 1. So we put 1 as the value here. Then we have f2 by 3. Note, I am replacing I with 2 here. Alright. So we have f2 by 3, which is going to give us f0, because we are ignoring the fractions here. We have f0 calculated here as well in this cell, indexed by 0. Hence, I put 0 in here. Similarly, f2 by 4 and f2 by 5 are going to give us f0 only. Hence, I'll put zeros in these cells as well. I add them up and I get 1, which is my second candidate. So which is bigger between 2 and 1? Obviously 2. So I'll populate 2 in here. Based on this approach, let's quickly fill the subsequent cells. So I now shifts to the next cell, and I now becomes 3. So we have our first candidate as 3 already. Let me eliminate this. Now we have to find our second candidate, which will be the result of the addition of this big expression. So fi by 2, f3 by 2, what it is going to be? It is going to result into f1 because we are ignoring the fractions over here. So f1 is already calculated over here, and I'm going to replace the value over here with 1. f3 by 3 is also going to give me 1, so I have the value calculated again over here. It is going to be 1. f3 by 4 is going to give me f0. 3 by 4 is going to give me 0. I am reiterating, we are ignoring the fractions, only considering the quotient. So f0 is already calculated over here. This is a basic dynamic programming problem. I am sure you are understanding it. So we have the 0 over here, and I'm going to populate 0 over here. Similarly, f3 by 5 is also going to give me 0. So what will be the addition of these four values? It will be 2. So we have got two candidates. One is 3 and one is 2. We are going to pick the maximum. The maximum is 3. So I'm going to put 3 over here. Okay. Alright, now I becomes 4 for me. Let me eliminate these values over here. I becomes 4. f4 by 2 is going to give me f2. I have f2 calculated over here already. So this value becomes 2. Then f4 by 3 is going to give me f1. So f1 is already here. And this becomes 1. f4 by 4 is going to again give me 1, so I am going to put 1 over here, and f4 by 5 is going to give me 0, so f0 is 0. I will put 0 over here. What will be the result of the addition of these 4? It's going to be 4. Alright, so we have 4 as our first candidate, 4 as our second candidate, which will be maximum 4 obviously. So I'm going to put 4 over here. Okay, now I becomes 5. Let me eliminate everything here and put I as 5. f5 by 2 is going to give me f2. We are ignoring fractions because, so f2 is 2. I'm going to put 2 over here. Alright, f5 by 3 is going to give me f1. So f1 is over here. I'm going to put 1 over here, and f5 by 4, what it is going to give? It is going to again give me 1. So f1 is calculated here. I'm going to put 1 over here, and f5 by 5 is also going to give me f1. So f1 again I'm going to populate 1 over here. Add all these up, I'm going to get 5. So we have both the candidates as 5. So what I'm going to place here? 5. So now I becomes 6. Okay, let me eliminate everything over here, and this becomes 6. So f6 by 2 is going to give me f3. So f3 is 3 from our array. I'm going to put 3 over here. f6 by 3 is going to give me f2. f2 is 2. Let me put 2 over here. f6 by 4 is going to give me f1. So f1 is 1. All right, we are going great. And f6 by 5 is going to give me again f1. All right, so f1 is 1, so I'm going to put 1 over here. What will be the result of the addition of these 4? It will be 7. So we have got the first candidate as 6 and the second candidate as 7. Which one is greater? 7 obviously. So I'm going to put 7 over here. Note that we have got a change over here if you are noticing. Okay, I becomes 7. I eliminate everything over here, and I become 7. 7 by 2 is going to give me 3. So f7 by 2 becomes f3. f3 is 3. I place 3 over here. 7 by 3 is going to give me 2. So f2 is 2 from our array. f7 by 4 is going to give me f1. So f1 is 1. I'm going to place 1 over here, and f7 by 5 is going to give me again f1. So I'm going to place 1 over here. What's the addition result? 7 again. Okay, so both the candidates are 7, hence I'm going to place 7 over here. Now I becomes 8, so I eliminate all these first, place 8 over here. So if at 8 by 2, so f 8 by 2 becomes f4, f4 is 4. Cool. And then we have f 8 by 3, so it's going to become f2, f2 is 2. Then we have f 8 by 4, so 8 by 4 is going to give me f2, f2 is 2 again. And f 8 by 5 and f 8 by 5, what it is going to be? It is going to be f1, so f1 is 1. Let's add them up. What is the result? 9. Cool. So we have one candidate as 8, another one as 9, so we are going to place 9 over here. Okay, now I moves one cell to the right and we eliminate all these values. Cool. So I becomes 9. Here 9 by 2 is going to give me f4. Alright, so we are going to put 4 over here. 9 by 3 is going to give me f3, so it is going to give me 3. 9 by 4 is going to give me f2, so the value will be 2. And 9 by 5 is going to give me f1, so the value will be 1 over here. Alright, so the sum comes out as 10, and I'm going to put 10 over here. Between 9 and 10, which is greater? 10 obviously, so I'm going to put 10 over here. Now I moves one cell to the right. I eliminate all these numbers, so I put 10 over here. f10 by 2, what will be the value? f10 by 2 is going to give me f5, so f5 is 5 over here. Okay, I'm going to place 5 over here. What will be f10 by 3? It will be f3 obviously, so f3 is 3. Cool, I put 3 over here. And what will be f10 by 4? It will be f2, so f2 is 2 over here. Let me put 2 over here. And what will be f10 by 5? It will be f2, so f2 is 2. I'm going to place 2 over here. Add all these up and what do I get? 12. So first candidate is 10, another one is 12, which is bigger? 12. And this becomes my answer. Like we already saw in the previous slide, that the maximum sum from a given n, which is 10, that we get using this function will be 12. Now let's take a look at its algorithm. This is the algorithm where SLN is our solution array. So SLNI is going to be maximum of either I or the addition of SLNI by 2 plus SLNI by 3 plus SLNI by 4 plus SLNI by 5, like you saw in the explanation. So this concludes this video. I hope you enjoyed watching this video. I hope you learned from this video. Do give it a thumbs up. I look forward to help you with programming and algorithms. And only for this video, goodbye and take very good care of yourself. Thank you.